Coming up on This Week in Radio Tech, Joe Fleming is our guest. He's an engineer at Virginia Public Media, and he's taking care of a number of FM transmitter sites. Joe's taken a real interest in HVAC and all the things that surround that, how it works, and also integrating that very tightly with a remote control system to keep strong tabs on it and keep his equipment lasting a whole lot longer. Check it out. Joe Fleming is next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. Good afternoon, good evening, wherever you are. I'm Kirk Harnack, your host, and we're here in the Telos Alliance studio in Nashville, Tennessee, where it is a very typical December day in Nashville. It's cloudy and cold and just not the kind of day you want to spend a lot of time outside. And am I complaining? Not really, because I know a whole lot of the country and our friends to the north in Canada and other places are a whole lot colder. Last week, we came to you from Saskatoon in Saskatchewan, Canada, and it was 6 degrees when I woke up in Saskatoon, about 10, 12 degrees when we got to the location of our dealer there, Pippin Technical Service, and they said they were having quite a heat wave. Normally, it was a whole lot colder than that in Saskatoon, and I brought a coat, but it was appropriate for 10 degrees, not for minus 6. Glad to be home. Glad to be back in the seat here in Nashville, Tennessee. As I mentioned, I'm Kirk Harnack. Chris Tarr is on the road and could be joining us during this show. I sure hope he does, because he certainly has some things to add to our topic today. And what about our topic today? Well, let's introduce you to our guest for the show, and that is Joe Fleming, or Joseph Fleming. Joe, welcome in. Good to see you.
Hi, good to see you too, Kirk.
Yeah. Hey, do you go by Joe or Joseph? What do you prefer?
Joe.
Okay. All right. Good deal. Joe, I don't remember when or where you and I met. Probably at several different trade shows. When's the last time we saw each other in person?
Last time we saw each other in person was Wisconsin a couple weeks ago.
Yeah. Okay. Or months ago, maybe.
Whatever it was at this point. Yeah.
Time flies.
Yeah.
That's right. At the Wisconsin Association of Broadcasters, and their broadcasters clinic. So, Joe, you're in Virginia. Tell me about what you're doing now. What's your responsibility in engineering right now?
Sure. I work for VPM, which is Virginia Public Media. We have several TV stations and a slew of radio stations, basically across the state of Virginia. I have all of the engineering duties on the radio side that I share with one other person, and then the TV side has several additional engineers. So the whole department has a staff of at least 5 or 6 maintenance and transmitter and studio engineers. Basically, myself and Mike Friedman split the duties of the radio side of the operation. It involves 3 FMs in the Richmond Metro and 2 additional, about an hour and a half one direction and an hour and a half the other direction outside of the Richmond Metro area.
Yeah, actually, when I was chatting with Mike Friedman, either Mike or you mentioned that, and I just something I hadn't cleared up in my mind. Those FMs that are, as you say, an hour and a half either side of your Richmond market, are those at all hitting the Richmond market, or are they serving completely different markets?
They don't really hit the Richmond market. One of them is in the Richmond Extended EAS operational area. The other is just a little further. It's actually in a different operational area, but they're both smaller coverage footprints, so neither one really gets into the Richmond area itself, per se.
Okay. I got to tell you, tell me a little bit about your companion there behind you. I mean, I know it's Big Bird. We've never had Big Bird on the show before, so tell me about your choice of. And Cookie Monster's behind you too, right?
Cookie, yeah, Cookie's over on that side. Yeah,
Okay.
Big Bird even wanted to put his headphones on. He's jamming out to everything, but we actually have, because we have both NPR and PBS operations here, we have those characters throughout the place in various combinations. These are cardboard cutouts. We also have some close to life size full 3D ones,
Mhm.
and I looked at them and said, I think I'll go with the cardboard cutouts.
It's a lot easier to fit in the room with you. In fact, I've had these radio stations for years down near Greenville, Mississippi. And there's a little town that actually one of our stations, one of our FMs is licensed to Leland, Mississippi, which is the birthplace of who? Jim Henson. How about that? And there's a Jim Henson Museum. It's a small house. I guess his family has made a tribute to Jim. It's been there for a while. My kids have actually been there. My mom took my kids there, and yet I haven't been to it. I need to stop in and spend an hour or two there at the Jim Henson Museum in Leland, Mississippi. But that is so cool to have that connection, because all of us, I mean, whether they're my age, your age, younger, even older, we all have a little bit of Muppets in our background, don't we?
Oh, yes. Yeah.
Yeah, and whether it's from learning to count or from the Muppet Show or the movies, it's certainly been an enjoyable connection for people of lots of different ages.
Yeah, Jim Henson was a very stellar person, and I actually had the opportunity a couple of years ago, of all bizarre things, on a cruise, of meeting the wife of the person who was the original Big Bird for years.
Okay. Wow. I can't imagine. Hey, someplace I got to go, and I realize we're just getting started with chit chat here, but we do have some real engineering topics to talk about. So if you're here for engineering, hang on. We're going to talk about some interesting things. Plus, we have charts and graphs. The show's going to be great when we have charts and graphs, because Joe brought some. And now I forgot what I was going to say about the Muppets or Jim Henson. Oh yeah, I know what it was now. I got to be part of or sit in on filming of an episodic comedy show, a TV show that NBC had bought, but yet it never made it to air. They shot and edited about 6 episodes, and the NBC execs came in and said, we're just going to go in a different direction. It would have been hilarious. Imagine the satellite radio version of WKRP in Cincinnati. Okay, that was that was going to be the show, but it got axed. And however, I got to go to where the facility where they were filming this in Queens, New York, and one of the sound stages in this campus of sound stages was where they shoot Sesame Street. Every week or however often their shooting schedule is, they had this, and I got to walk through the current Sesame Street set, which is actually in Queens.
That's cool.
That was fun. They also shoot. They were shooting Orange is the New Black. About the women's prison. They were shooting that there too. So.
Yeah.
Anyway,
and of course, we go full out on it. We've actually been in this facility for 60 years. And our mailing address is Sesame Street, even though it's Richmond, Virginia. But I have this because we're actually moving away from Sesame Street to go downtown, close to where the rest of Richmond is.
Oh, okay. Wow, that's got to be a big move to move. Radio and TV both are moving?
Mm-hmm.
Yes. Wow, we need to talk about your planning on that, and how, what kind of things you have to think about in making that kind of move, and how much stuff you take with you, and how much is new, and what technologies, what does the new location present itself in terms of challenges and different technologies to be used. But we'll get to that. Hey, our show This Week in Radio Tech is brought to you in part by our friends at Nautel. And you may have noticed that Nautel has not been doing their Transmission Talk Tuesdays for a little while. People like Jeff Weldon, well, Jeff is typically the host of the show. He, like myself, we've been on the road quite a bit and resting up a bit. And I know that Jeff will get back into doing Transmission Talk Tuesdays. But I want to remind you that Transmission Talk Tuesdays are archived, and they are all online at the nautel.com website. Go to nautel.com/webinars, and you can choose from all different topics. There's the Transmission Talk Tuesday archives, but there's also then categories, how-tos in the HD radio world, for example, and how-tos in in the single frequency network, or if you want to know about STLs or disaster survival, digital radio of different types, you can click on any of those, and that'll bring up more options, more shows, more, hour long or approximately hour long or webinar length video presentations on these different topics. Winter is a great time for us as engineers to continue learning. And Northern Hemisphere. You in the Southern Hemisphere, I know you're outside right now and you're doing work out of doors. But here in the Northern Hemisphere, chilly, cold, we get more time inside, and maybe you've got an hour here and there. Maybe you can start a webinar and finish it later. But there's all kinds of topics that we can get ourselves better educated on, kind of like what we try to do here on TWiRT in a more conversational fashion. So check that out from nautel.com/webinars. And while you're on their site, of course, if you want to check out their AM transmitters, FM transmitters, digital broadcasting, those are all options that are online as well. So thanks a lot to Nautel at nautel.com for sponsoring This Week in Radio Tech. All right, Joe Fleming is with us. And Joe, our topic, I wanted to chat about HVAC, heating, ventilation, and air conditioning, and how it applies to transmitter sites. And I realize there's hardly two transmitter sites that are the same. So they all have, different schemes, different needs. And I guess as people have changed technology from tube transmitters over to solid state transmitters, not that solid state doesn't need cooling, it still does. In fact, it may need a similar amount of cooling typically than as a tube transmitter does, but the air typically is handled a little bit differently. Or maybe it's a liquid cooled system like we've had in television for years. Some FM transmitters are as well. So Joe, I understood from Mike Friedman that you had taken a real interest in working on HVAC improvements in your facilities, and you could kind of start us out how that topic came up for you and what's been your journey through it.
Sure. Part of it just was sort of a spin-off from the world of COVID. I was actually doing a lot with our remote controls. So once I start monitoring one thing, I start monitoring something else. Once I start monitoring something else, then I start tweaking that and say, hey, let's look at such and such. And I start to end up getting to the point where I'm noticing little trends and patterns in things that become an issue. And I catch things such as a couple of weeks ago, we had one site where the main air conditioning unit was doing its job, but because I happened to be working out there, the alternate unit was not at all doing anything and had its own issue. And I've been ending up catching more and more of those kind of things, whether it's through the Burke system or being on premises or some other combination.
Okay. All right. We've got some. I don't know which graphics you want to jump into. See, I guess what I'm hearing from you, I didn't expect, but it makes sense that your interest in making sure the HVAC systems were working properly at your sites and optimally, helping to keep the life of your equipment as long as possible. That goes hand in hand with monitoring those things since you're not there all the time, and that's where the Burks have come in, right?
That is correct. Yeah. I actually have several. Let's pull up one that is called Burke WBBT2 as a good example.
Okay.
Burke gives the ability for graphing over a duration of time. So not only do you see something that is current and say, at this exact instant, the room says 68 degrees, but on a graph like this, you can actually graph multiple things. And I've got the two air conditioning units, the ambient temperature. Our main transmitter is a Gates Air 3K, and then our aux is a BE older unit, and the TPO is about 2,800 watts. But I've got all of those graphed on there, so I can look at them, and it doesn't seem to come through very well on my laptop. But ultimately, there's 5 lines there with different colors and different combinations of shapes, so that you can see exactly what each one is doing.
Yeah,
And
I see them all here. The aux exhaust is the same color, almost the same color as the grid lines, but and it's perfectly flat too. I guess because it's not doing anything, right?
correct, yeah.
Yeah, the aux.
And one of the interesting things that I learned early on is, for instance, on the main, and it says that it's 109 degrees Fahrenheit. The Fax 3K units, depending on the frequency that they're on, you would expect, hey, that seems like a higher than I would have anticipated temperature when you convert the Celsius to Fahrenheit. But then as it varies depending on the frequency, this one is on the far, far upper right end of the dial at
Hmm.
107.3. So
Hmm.
it generates more heat by being there than if it was, for instance, we have an almost identical system as the backup to one of our other stations on 88.9. There's
Hmm.
about a 15-degree difference just by being at the opposite end of the band for each of those. Um,
Wow.
yeah,
Wow.
but you
So,
were talking about the way the
mhm.
airflow goes in and out. Those are only, I think it's 5 rack units tall, so
Mhm.
the idea of suck in at the bottom and go out through the top like we're used to with the tube transmitter really doesn't apply when you're only dealing with 4 or 5 rack units.
Right, right. Do these draw air in from the front of the rack and then expel it out the back, or how are they designed?
Yes. Yeah, these
Okay.
draw in
Okay.
from the front, and I've found out from Gates Air where they have their sensors on them, and you can tell by looking at the back is 109 that the sensor on this particular unit happens to be on the back right before it's exhausting out. Um, I always
Okay.
strive to have the room temperature. I used to have air conditioning people say, maintenance people say, "Well, what do you want in the room?" And I put it in terms of the equipment is just like the humans. Humans don't want 90 degrees, and the equipment doesn't want 90 degrees. We can probably suffice in both cases, but when you're looking at a 40-degree spread and 109 degrees on the output, if you're only starting at 85, 90 degrees in the room, you're not starting at a good place to end up for the transmitter.
Right, right. Obviously, yeah. Let me ask you about now. There's 5 temperatures that are shown across here. Obviously, the Flexiva rear, the aux exhaust, the ambient temperature. I take it in the room, and then the HVAC number 1 and number 2. Are those HVAC number 1 and 2? Are those monitored right at the output of a duct where the
Yeah.
air enters the room?
Um, yeah, in that particular site, they're actually it's a small site. Like I said, the TPO is 2,800 watts. So those are it's like the cellular building type 10-foot by 20-foot building. And
Hmm.
those are Bard units that are right at the end of the building.
Oh, sure.
And
Yeah.
then it's just the Burke sensor positioned several inches in front of the duct. And when the actual unit turns on, it goes down to 45, 50 degrees Fahrenheit and shows that way. That screen capture that I grabbed last night happens to have them both not running at that particular instant. So, actually, I see some up and down cycles. So, if you're looking closely, those little bumps of one of the blue ones going up and down is when that one is cycling on every once in a while.
Sure, and you know what I noticed if you look carefully with that graph, and hey, Suncast, if you want to pop that graph on for just another second, the temperature at the output of the Flexiva, um, uh, uh, about a minute or two later than you know when the HVAC number 1 when it turns on and gets colder by several degrees, the output of the Flexiva also dips a minute or two after that,
Yeah.
and of course stays lower for a few minutes even after the air conditioner has shut off. So that's as you would expect
Yeah.
that the Flexiva rear temp trails just a little bit the air conditioner going on and off.
Yeah. And actually, for that particular combination, one of the things I wanted to talk about was it's important to try to keep a relatively consistent life between the two units. They're basically identical units. And off the top of my head, I feel like basically they're approximately the same age. Um, so it's nice to be able to run one for a week and then run the other for a week and back and forth like that.
Mm.
And we get a lot
Hey,
of other factors that come into play that I
mhm.
want to come back to, but that one is the one that's actually blowing towards the rear of the transmitter this week, just by the
so
nature
so
of
I've
where
got
they're
a
positioned.
I've got a question about the Bard units. That if you can't answer, that's fine. I need to go, find a real source, but maybe you know. Um, we built a new FM station in Oxford, Mississippi this past summer. It's been the topic on several shows. And my business partner bought a used prefab building that had the 2 Bard units, and they came guaranteed working. Of course, one of them wasn't. So the guarantee paid for a local HVAC firm to come fix it. And I notice, of course, the controller for the Bard units, good size, about the size of 2 or 3 shoe boxes, brown box, and below that on the wall was mounted a very kind of standard looking thermostat that you see in a lot of homes and businesses. And but no documentation came with this whatsoever, and no obvious controls other than the temperature setting, no obvious controls as to how to make one of the Bards primary and the other one secondary, or make one the main and the other the backup. And I haven't ventured to open this box yet to have a look inside. Is this similar to the arrangement that you have, or am I looking at a completely different control system than what you have?
It sounds like it's similar. We've got one that sounds like it's a slightly different physical size, and it's a silver color. And there's some information on the front when you hit the different buttons that are there as well,
Hmm.
and you can basically get into menu options that way. It sounds like this is just a variation on that, and ours actually has the instructions basically on the front. You have to hit one key twice, and then you can get into the up down, and it's a typical menu tree where you can choose between 10 different options, and then what do you
Oh,
do on each of those 10 options.
well, that's the big difference. Mine has no screen. It has no buttons, no menu. It just below the plain box, which obviously must have some relays and such in it. Below that is the off the shelf industrial thermostat, and but there's no controls on the box. So I need to research that and probably open it up and see what's inside.
Yeah, and sometimes maybe
Yeah.
the easiest answer is like we actually did at one of our other sites. We've gone through some combinations with that one, and actually that segues into the ones that I've got called that are NT1 and NTI1 and NTI2.
Okay.
Um, that is actually a different monitor that I'm pulling the stuff from SNMP, but it's a little device that's called NTI, and it does temperature by default. You can get humidity as well, and the whole thing's like about the size of a man's wallet or something. And that's mounted in the room a couple of feet away from the units. But we actually had a problem at this site where the controller that they put in there was not a Bard controller, but it was a different brand, and it really wasn't positioned very well with where they positioned it. So we've moved it around a couple times. We moved the sensor a couple of times. We got to the point where we finally said, you know what? Let's just go old school, put 2 individual thermostats in there and choose this new location. And that's working a lot better. In fact, where you sort of see the trend looks like it has suddenly changed. I feel like that's where they did a repair a couple of weeks ago because we had an issue with one of those thermostats. But
Oh. Mhm.
um, sometimes that's the easiest way is just go old school because the actual Bard unit, if you're lucky, it has an economizer, and otherwise, it may or may not have heat coils in it. And then it says turn on or off for air conditioning. So the basic logic for a single unit is not complicated. And then it comes down to, well, if I've got more than one, what do I want to do? Basically, the short version for that is it's nice to keep them getting the same amount of hours. Like you're at a site 5, 6, 8 years that you work for an employer. If one of them's
Mhm.
running all the time and the other never is, well, the
Yeah.
one's going to fail real soon. Um,
Hey, I'm
but
I'm curious on those the NTI box that you mentioned. I've got a couple of them pulled up online that I'll put in the show notes. But do you have the kind that monitors just one temperature for the box, or do you have the one that you can string several temperature sensors to it?
we don't have any temperature sensors on it, but if I remember
Oh,
correctly, there's a
okay.
small barrier strip or Phoenix block or something where I can add 1 or 2 extras, and then it's got one that's internal.
Okay. Okay. Good. All right. I'll put both in the show notes. So they sell one to which you can add up to 24 temperature sensors through what looks like satin cable and RJ connectors, and looks like older telephony kind of kind of connectors, maybe 4 or 6 conductor, and you can add. Temperature sensors that way. So anyway, I'll put those in the show notes if people want to have a look at either what you have exactly or something pretty similar.
Yeah, and talking about remote controls for a second again, we have Arc Pluses at most of the sites, and when you've got 256 channels of metering and 256 additional channels of status, it's like, you can meter all kinds of combinations. Get the room temperature over there, get the room temperature there, get the transmitter intake, get the transmitter outtake. If the device gives it to you, you've got the room to just add it all on there. We just happened to have these around before we had an Arc Plus at that site.
Gotcha. Gotcha. So, all right. Was there another graph here? The NTI two? Yeah,
Yeah,
yeah. What is
one
this
is
one?
7 days and one is 30 days.
Oh, okay. All right.
Yeah. And one of the things that I wanted to bring up, because this one on the 30 days, I think that's the one that shows it more clearly. If you're looking around November 1st, you can see the
Mhm.
trend prior has a several degree fluctuation, and then it drops and it's got a whole different range. Um, that's obviously got to be where we made one of the changes. That might be where they repositioned the thermostats. That might be where it was actually brand new thermostats, and one of them was bad out of the box.
Oh my gosh.
And they changed it or whatever. But you can see the trend. We're hovering only about a 2 or 3 degree spread in the building from 69, 70 to topping out 73, maybe 74 on probably a couple of days there in the end of October. And then you see the whole trend get several degrees cooler. Um, but over the course of the longer time, we use that monitoring. We say, okay, so the site itself is maintaining the way we want to long term as well.
I can, but by this graph, I can just hear my wife say something near the peak of each temperature and near the bottom of each temperature. It's I'm too hot. I'm too
Mhm.
cold. I'm too hot.
There's an old
I'm
saying
too
about
cold.
relationships. Relationships are two people always fighting over the thermostat.
That's about right. Hey, we'll continue on here and get more comments on this because I got questions about whether these things are tied into Burke or you use them separately. Just how you have this configured. It's Kirk Harnack with Joe Fleming. Joe is our guest today, talking about HVAC systems, and we're going to get into talking about, or maybe speculating about HVAC systems during the wintertime. Depending on what your climate is outside, are you really cold in the transmitter building? Are you directing some of the transmitter heat back in? Do you just, does the air conditioner just not come on as often or at all because it's so cold outside? Keeping the building somewhat cold depends a lot on a lot of factors. So we'll be talking about that. Our show this week in Radio Tech is brought to you by a couple of great sponsors, and one of those sponsors is Angry Audio. Angry Audio. And if you go to the Angry Audio website, one thing that you'll notice, I want to talk for a minute about this Rave audio console. I'm a little bit qualified to do that because I've gotten to take several peeks at it. So Suncast is going to have a look at the Rave console. This Rave radio mixing console, it's built for radio. It's not built for mixing. It's not a Behringer. It's not a Mackie. It is built for a small radio studio, or even being your main mixer. It can do that as well. It's got mic preamps. It's got 2 stereo output mix buses, your traditional program and audition. It has a very flexible monitoring section for your board operator. The faders are the knobs to control your speakers. Those are the same faders as you use for the channels, which is pretty convenient. They're full throw faders, so they're easy to see where they are and easy to move up and down. Your brain, your hand just knows what to do there. Channels 1 through 4 are switchable between mic and lines. There's built-in mic preamps there. Channels 5 and 6 are switchable between pro level, +4 balanced, or IHF levels. That would be your -10, your RCA type connector. You can switch it to that. So you don't have to use an interface box to go between, say, a consumer CD player and the console. Or if you're using a cassette deck. Channels 7 and 8 are capable of generating mix minus feeds. So if you have a phone system or a codec that you want to have hooked up, or maybe in the modern times, maybe you're using a computer to take Skype calls or Zoom or Microsoft Teams or Google Meet, you can generate a mix minus and come out of that and go to your computer sound card just for that. The power supply is internal. So there's no wall wart. It's internal power supply, and most of the connectors on the back, they are the Studio Hub standard. So those are easy to wire to, easy to use. They do have some XLR connectors if you want to use those for your microphones. Really cool little console, and the list price, $2,000. Get your exact price from your favorite dealer. And Angry Audio goes through a lot of different dealers. You can find a list of them at the Angry Audio website. So check it out, angryaudio.com. angryaudio.com. Thanks a lot to Angry Audio for sponsoring This Week in Radio Tech. Our show is also brought to you by Max Connect. They have a whole range of services. Josh Bone and Max Connect started sponsoring This Week in Radio Tech just on the strength of the Max Connect wireless product line. And that was, the 4G LTE modems. They still have those. And those are the ones that have, I don't know if you can call it guaranteed bandwidth, but they have prioritized bandwidth. Your data is prioritized over everybody else at the parade or at the stadium or in the arena. You get prioritized packet data and a fixed IP address. So if you've got a transmitter site that you've got no other way to get IP, to get an internet connection out there, a great way to do that is with the Max Connect wireless box. I've used them several times WEVL in Memphis, Tennessee. They were on an IPSTL, and Comcast just completely failed them. They had some major difficulty, and I think Comcast was down for about 4 days. Well, we got a Max Connect wireless modem out there for them, got them right back on the air, and it carried them right through their fund drive. So that was really a critical time. So thanks very much, Max Connect. I've used it also at a transmitter site of mine where we were promised fiber connectivity, and we didn't get it until 6 weeks after it was promised. So I ended up using a Max Connect wireless box to finish configuring, maintaining, and we started doing programming through the Max Connect wireless. We ended up, getting the fiber, getting on that, and we do use a whole lot of data on the fiber. So it really saved our bacon. I've talked to plenty of engineers for whom it's saved them as well. Max Connect also offers engineering services. So if you've got a project going on, something that you're too busy to do or too busy to do right, or you need some help, or you need somebody to bring extra tools. So Max Connect Group now offers engineering services over a good part of the U.S., and you ought to contact Max Connect for details on that. Thanks a lot, Josh Bone and Max Connect Wireless, for sponsoring This Week in Radio Tech. I should say Max Connect Group. And the website, Max Connect, I know it's spelled funny, so it's in the show notes.com. All right, we're talking to Joe Fleming. He is an engineer for Virginia Public Media, VPM. We're talking about HVAC systems. Joe, at your transmitter sites, do they kind of require air conditioning 12 months out of the year, even during the dead of winter?
Pretty much, yes. Actually, if we can pull up the one that Jeff sent from Nautel, we're talking about heat load. I think it might actually be called Nautel 1. Really, every transmitter site requires some amount of cooling, even in the winter, and it's all in how you get there. We've got a couple that one is 2,800 watts, so it's much lower power, and when you do the math on it, obviously requires a lot less. Then we've got another one that is 14 kilowatts FM plus HD. Well, obviously that consumes a lot more HVAC. But pretty much all sites you need something. Unless you're in that place in the country where it's maintained 69 degrees outside in the air every day, please tell me where that is. You need something at some point. You need heat, you need cooling. The equipment likes to be at what we call room temperature, the 68 degrees thereabouts temperature range. So the further away from that it is, the more you've got a problem really in either direction.
So I'd like to talk about that for a second. When we as engineers talk to somebody who pays the bills for purchasing an HVAC system, or paying to repair it, or paying the electricity, or other, if the heating is run on natural gas, paying those bills, they may say, well, why can't that equipment run at 80 degrees or 90 degrees? Why does it have to be, or why should it be at 68, 70, maybe 75 degrees? When you get asked that question, Joe, what's your answer as to why equipment wants to be at room temperature?
Basically, the lifespan of it, the reliability of it. The more it is not at that temperature, the higher the heat is, and there will be a failure point. The electronics themselves fail at some point. Is it 40 degrees higher than that? Is it 25 degrees higher than that? Whatever amount, somewhere along the line, it basically shortens the life, and it really does become a pay me now or pay me later kind of scenario. But there's more than one way to accomplish it. Like you said, the air
Mhm.
conditioning might be a very expensive way. Um, I'm originally from upstate New York, so well, wait a minute. It's only 20 degrees Fahrenheit if you're lucky on a lot of days up there. So why do we have to run an air conditioner? You're right. Maybe there's another way where you can do something with outside air. And some air conditioners have what they call an economizer mode, which is exactly that.
Hmm.
In lieu thereof, what I actually had at one site in Rochester used a variable system that instead of a fixed thermostat where you set it at whatever value, 69, 72, or whatever number you choose, and it's a hard on or off relay type thing that says turn the air on or off. This was a variable. So it was varying a motor speed that would exhaust the air out of the room temperature and outside.
Mhm.
The actual three phase blower motor would change depending on the temperature in the room. And sometimes they would only be running at like 10% of the full speed of the blower. But then if the room got a little warmer, it might be running a little bit more, and it automatically louvered to the outside air. So a lot of the times we could get away with not running much air conditioning, especially in the winter months. It was a 17 kilowatt, and we were doing high level combining HD. So we're generating our share of heat inside the building.
Mhm.
But in the middle of winter, we didn't necessarily need to pull it from air conditioning units. We could suffice with the stuff that was being sucked in from outside, filter it a little bit, keep it clean, try to monitor the humidity and everything, and then send it out that direction. And it works pretty well. The catch comes down to, well, especially in a place like Rochester, New York, it's 20 degrees right now in December, and
Yeah.
it's 95 degrees in July. What do you do then? Well, you really need to have the logic that ties it all together and says, all right, so if I get above a certain point, I'm sucking in 85-degree air. It doesn't really make sense any longer to try to run that through the transmitter because I might get with enough actual flow, I might make the room feel a little worse, but you're still not back to that 68 degrees. So that's where the logic really needs to say, all right, let me shut that system off, ideally automatically, and turn on the air conditioning units, and then use your 4 tons of air conditioner and dump that into the room so that that keeps it maintained and everything.
We've been talking about temperature, and there may be exceptions to this. Let's talk for a minute about humidity. If you recycle inside air by air conditioning it and you have a closed system, your air is probably going to remain fairly dry. There's nothing really there to bring a lot of moisture in. In the South, I've got stations in Mississippi where prior to having closed systems, we would exhaust hot air from the tube transmitter. We would draw in outside air. At some sites, we would try to air condition that outside air, but that outside air was just loaded with moisture during the summer, during the fall, during the spring. I think at most times, except during the dead of winter, that air is very moist, and the latent heat of water or moisture, um, uh, that's pretty significant. In other words, you can do a calculation to figure out: am I better off air conditioning the moisture laden air that's coming in from the outside, or would it be cheaper to have a closed system and keep air conditioning the same air over and over again? And you got to take into account that latent heat issue, because it's hard to condition moist air down to a lower temperature because of the heat of the moisture that's in it. Anyway, what I'm getting
Exactly.
at is, if you're the good news is, if you're in a cold climate, probably that air is dry or fairly dry, because dry air doesn't hold very much moisture, or cold air doesn't have very much hold very much moisture. My my question to you is: do you have to take account humidity in thinking about how to cool or maybe heat a transmitter site?
Yes, definitely. As you were saying a while ago, every site is different. You might have a site in Mississippi where that humidity is ridiculously high all the time, and maybe 50 miles away in Mississippi or one of the adjoining states, you've got the right combinations where, wow, they actually have low humidity for a couple months out of the year. It's very site dependent. Rochester, New York, yeah, we get about 3 weeks where it's just horrendous humidity in July, but the rest of the time it's not. So you can get away with it until it becomes some of the extremes. But Virginia, it's a very different ballgame where I am now. Winters are much more mild, but then the summers are very definite, sometimes humidity and a lot of heat. So, yeah, you got to walk that line with all of the above. And what may work in Rochester may not work in Richmond, but it might work in Buffalo, or it may not work in Scranton, Wilkes-Barre, for example, or whatever.
Okay. Yeah. So I guess the advice of a qualified local, maybe commercial HVAC company would be very beneficial. And it sounds like if you that I was curious about the system that you described earlier that had the variable motor that had the I'm not sure what you called it. It wasn't bypass, but I was thinking of it as bypass, where you're drawing cold air in, maybe conditioning it a bit, or maybe not. And so you have this economizer mode. What if you were interested in getting that kind of technology for your transmitter site, what would you talk to your HVAC contractor about?
Well, one of the things I've learned is HVAC contractors fall into the weird two realms mode. Some of them really get all of it. And if you want to say, I want to do basically that, and you describe the system in a couple of sentences, they get it. A lot of them, they also understand the basics of, all right, thermostat, air conditioning, compressor unit, intake temperature versus outtake temperature, do a little bit of math, and make sure the Freon works accordingly. Sometimes it comes down to you may not have the right vendor and you need to search around and find one who gets more of that bigger picture as you start to describe it, because that really makes the difference if they understand exactly what we're describing in this regard.
Yeah. Yeah, I know. Sometimes I know there's good companies in Mississippi, but I tell you, in rural Mississippi where we were, I would always like, let's say we built a transmitter site and we'd put it in some kind of shed. This was low dollar, and it was a tube transmitter. So we're going to shove all that hot air outside. We're going to draw air inside. We're going to blow it through a fan, and we want it to be low velocity, and we want a big surface area for the filter. And I would tell that to the HVAC company, and they would build nothing of the sort. Of course, they would have a little 16 by 16 filter, and they would just shove air through it at a really high velocity. And of course, the filter didn't last, didn't do well. If it rained outside and moisture got sucked up onto it, the filter would collapse because it was now wet. Yeah. It's hard to find people that are really knowledgeable, but obviously
It
well
is.
worth it, right?
Yeah. And it helps to have some of the knowledge ourselves too, because if the problem happens to be, well, I don't have cooling at my site and it's the middle of July,
Mhm.
it's probably a capacitor on the motor or something like that, because that's the most common failure.
Mm.
Almost every HVAC guy can find, troubleshoot, and do that repair. But it's when you get down to some of the design of, well, I've got one room or I've got 5 rooms and I've got several different transmitters in each one or anything like that. How do they deal with all of the above? And the more information that we can give them, the more the skilled ones can really make it happen for what we want.
Yeah, yeah. All right, we've got maybe another graph or two to show you as we move along after the break. You're watching or listening to This Week in Radio Tech with Kirk Harnack and Joe Fleming, and our show is brought to you in part by Broadcasters General Store. You can get anything you need for broadcasting at bgs.cc, Broadcasters General Store. I mean, if you are adding television lighting to your radio studio, they've got that. You want to add television cameras, PTZ cameras, or fixed cameras, camera switching systems. They got that. But I'm here to talk to you about something else that's small, automatic, efficient, and that's from Broadcast Tools. And that is their silence sensor from Broadcast Tools. It's called the Audio Sentinel Plus WebRJ. It's a web-based analog silence detector. So you run your program audio into it, And it's also a 2x1 switcher, by the way, but you can hook it up to your internet connection and have it send you text messages. It has an HTML5 web-enabled browser that's built into it, so that's pretty cool. It's got a whole lot of features that we can use. You know, in a few minutes ago, Joe was talking about the NTI brand of sensor that can, of course, monitor temperature. They have ones that can monitor other factors as well. In other words, you have these little devices that do things automatically for you, that take worry away from you, that alert you when there's a problem, and let you go back and look at problems later. Well, the Broadcast Tools Audio Sentinel is pretty similar. Again, it has that built-in web server to provide a simple web-based notification, monitoring, configuration, and control. It's powered by an ARM Cortex processor. It has support for Start TLS secure SNMP authentication, so it'll work with Gmail and other things that need that protocol. The front panel, it has front panel, remote, and web-based switcher controls. So even if you're remote and you need to switch the audio from one input to another to keep yourself on the air or to bypass something that's a problem, you can do that even remotely or from the front panel. You know, you could send one of your disc jockeys or board ops over to it and take care of that. Both of the stereo inputs feature silent sensors, phase monitoring, that's kind of cool, and front panel activity and alarm LED indicators. You can adjust the silence trip level over a wide range in 1 dB steps. It has a very precise alarm delay, so it's not just a pot you're turning. You're actually setting it digitally in 1 second increments for each channel. And the alarm restore time is also quite precisely settable and, of course, repeatable since it's digital. It has this internal transparent 2x1 switcher, and it operates with mechanical latching relays. You know, sometimes it's good to have older technology because a mechanical latching relay, by golly, it's going to stick where you stuck it. if you have it stuck to your backup chain and the power goes out, well, when the power comes back on, guess what? It's still on the backup chain. It's exactly where you left it, and you can depend on that. So many other features that make the Audio Sentinel WebRJ really cool. So check it out. You can go, of course, to the Broadcast Tools website to check that out. You can also get your best price from Broadcasters General Store, bgs.cc. That's the website, bgs.cc. And they got transmitters. That's on the screen right now, the Ecresso transmitters. They've got from Bolin Technology, a whole line of cameras and switching. Of course, they've got products from my employer, Telos Alliance, phone hybrids, codecs, audio consoles, audio processing. There's a Rave console. They got it all there at Broadcasters General Store. Check them out. Or, of course, give them a call at 352-622-7700. I think if you called them right now, somebody answered the phone. They do have extended hours. 352-622-7700. Thanks, Broadcasters General Store, for sponsoring This Week in Radio Tech. Joe Fleming is my guest, and we're talking HVAC systems. As we're moving into winter, you know, I always kind of wonder, okay, how does my situation change? Am I going to wake up one morning and get a call from the disc jockey, the transmitter's off the air, and I check the transmitter site and discover that it is, 18 degrees in there. And, well, that's bad. Something's really not right. By the way, Joe, I have a very kind of low-tech way for checking temperature at the moment at my transmitter sites.
Okay.
We use a $25 Wise camera, and we use a $9 round thermometer that's this big from Walmart. And we make sure that you can see it from the camera. What do you think? We can't see temperature trends, but we know what it is now.
Yeah. Hey, it works. As long as somebody actually looks at it, it works.
Yeah, that's true. That's true.
Yeah. But there actually is a lot more involved on the winter side specifically. You think, well, all those things that we're talking about specifically with the summer side, okay, so how much load per kilowatt on a transmitter and everything like that. But what about winter? One of the big things that we've probably all seen at some point or another is you look out and say, wow, I've got a ton of ice all over my compressor, and it's not from the weather, it's because of the unit. What happens is the Freon or the equivalent product that they're using nowadays is trying to get basically about a 25-degree drop. Well, if your outside ambient temperature is cool enough, you do the math on 25 degrees, you're below freezing, and that creates a problem. So they have a way around it. And it really, I think, especially if you've got a transmitter site, they get those freezes even in Florida. So you say, well, you know what? We have months on end and it's always wonderful in Florida. It never gets cold.
Hmm.
They have freezes. They have what they call a low ambient kit, and it generally deals with the head pressure inside the freon part of the system. And as that changes and it's looking essentially indirectly at the outdoor air temperature and realizing what it's doing based on that, what it does is it deals more compressor or less compressor and throws the fan in there. And you'll notice sometimes that the fan is just cycling a little bit and turning on and off. The compressor may never run, but it's pulling the air from the outdoors, cycling the fan part on the outdoor unit and sending that into the duct system so that you're still getting some semblance of 45, 50-degree air coming out of the ducts and aiming towards your room. That makes the world of difference because then you don't end up that you have all the icing on your coils. I mean, it still happens.
Hmm.
That's where you get your redundancy systems and everything like that. But that's how they get around that. So you think, well,
Are
I'm in
low?
Virginia and we don't need it.
Yeah.
Well, you never know.
Are low? I just looked that up. I learned something today. I'll provide some show notes into low ambient kits. Are low ambient kits, are they specific for your make and model of air conditioner, or are there kind of generic low ambient kits?
I don't know the answer to that.
Okay.
I think it's probably semi-generic. So some stuff on a vehicle, you get an oil change, it's an oil
Yeah.
change. But then there are some things that, well, I need to address specific item X, Y, or Z. Those are specific tires that that vehicle doesn't have the same tires or whatever. So I'm guessing, pure guess, that there's probably a little bit of each involved. But it is something that pretty much any contractor can install, and it does make a big difference because it's just a couple small parts that they put into the system where the freon goes, and it controls the electrical on the fan as opposed to basically pumping the compressor when it's just too cold outside anyway.
Yeah. Okay. All right. Well, there's some. I'll put some things in the show notes. People can get educated on that. I found a quick training video on low ambient kits meant for the HVAC industry techs. So that might be interesting too. Always good to know about these things, so that you, as an engineer, can speak intelligently with your HVAC rep, and you can instead of you being surprised or bamboozled, or in the worst case, ripped off, you can have an intelligent conversation with your HVAC contractor about these kind of things. Did you have any more graphics to show, or did we already look at all of them?
Actually, I have one we can pull up just because it's from our Burke where we're monitoring all of our transmitter sites. And
Oh,
again,
yeah.
this was captured last night. Yep. 8:21 last night, this was captured. And because Burke provides the color code capability when you're doing any of their customs, the blue is saying that the unit is running in some form or another. Like I see the
Hmm.
one on the right, HVAC number 2 at WCNV says 56 degrees and it's blue. I'm not sure exactly what I've got the threshold set to, but somewhere between 56 and 63. And if you look down below, it says that room temperature is 68. Um,
Hmm.
that becomes convenient because we actually have in our office here where we have a shared space between the multiple engineers. We have one computer that basically keeps autopilot on the Burke connected all the time. And I pull up some kind of screen and put it on a big one that we can all look at. So on a moment's notice, we just glance up and see what our system is doing, whether it's audio capabilities going on or whether it's the cooling, or I've got one that's actually built with shows all of our operations throughout the state and just shows the alarms that way and everything. It's real quick. What do we have going on our systems? And I have this is just one of the ones that I can look at and say, all right, well, it's 20 degrees outside and are my systems working? And I can look at all of them on a moment's notice and I've got all that information right there.
Nice, nice. Okay, and of course they skeuomorphism here comes into play. They look like wet bulb thermometers. Oh, that's
Yes.
kind of cool.
Yeah. It
I
actually takes a little bit
huh?
of finagling to make some of the combinations. I can't tell on this particular one. Some of them I've actually
Mhm.
redone the numbers so that they have ranges as well as the wet bulb thermometer having color depending on where exactly that bulb is lying. So you can look at it and say, okay, well, if it's 77, it sounds a little warm, but the system is telling me I want to be worried over 82. So I've made some of them where the numbers actually reflect that as well.
Nice, nice. I would love to see the temperature graph. Would you call that a longitudinal graph? I don't know. The left to right time in this way, and then your temperature readings this way. I'd love to see a graph, and maybe the BERT can do this. I'd love to see a graph that contains all manner of things that you are interested in over time. So maybe you could monitor if you're doing, let's say, a 950 STL, STL signal strength and temperature and audio, average audio level, so if your audio level drops or goes away or something, or, hey, that show we played from NPR last night was, a good 6 to 10 dB lower than everything else. That would be interesting to know. And you can see that on a graph. What else would you monitor over time? Well, you can see the tower lights come on and off. That might be interesting to see. You can probably think of some silly things too. How tall is the grass?
Now that would be silly. But yeah, all the rest of them, at least metering indications, BERT can do that. They do have a finite point that probably is tied to the resources of your computer. How many things are you trying to graph and over how long of a duration? Like if you've got one graph, but it's 20 minutes, that's a big difference than if you've got 10 graphs or 20 graphs and each one is 24 hours. There's some kind of a finite limit there. It's probably the limits of the particular PC that you've got the autopilot loaded on, but you can definitely do it.
I've talked about it being a useful tool before, but on a computer over here in my studio, I can't really easily show it to you, but I'm running a program called Multiping, and I take care of a grand total of 14 sites, or at least 14 internet connections, and I ping each one of them about every 30 seconds, and Multiping does that and graphs them over time. And there's just having it graph that over time is so extraordinarily useful. I've got a transmitter site in Arkansas that hasn't had internet service now in about a week. And of course, I've made some calls and nothing's happened yet. But I've got other sites that there'll be a bad night for one of the internet suppliers, and we'll get a lot of non-returned pings, but overall the internet's working. It won't be periods of outages. It'll just be, statistically lots of missed pings over time. And it's interesting to graph that and see how it goes. I've got a couple sites, Joe, and you may have the same thing where you have internet at the site, but it's provided maybe by a 4G LTE modem or a 5G gateway or something, or maybe Starlink, and you ping that. And it's interesting to see how other traffic with the carrier affects the ping time and the reliability of all these sites. Almost none of these are we carrying live audio over, but we are, doing security cameras and remote monitoring like you're doing with your BERT. So that's another thing I would want to graph over time is IP connectivity over time.
And we actually are doing audio on those two stations that I mentioned that are in the opposite hour and a half each way. Those are so far outlying that when Mike, the other engineer, started, there was their share of problems. They were less than wonderful. They could not be 950 STLs. We ended up that they had put an uplink system in, and we've actually recently changed all of that to Comrex systems. So we're doing audio IP-based with Comrex systems. And yeah, we've got redundancy now of the local internet provider, stuff that's coming in from a Verizon connection, and doing all of that and stitching everything inside the Comrex, because that is our audio.
Yeah, so you're using more than one path. You have redundant IP paths, and that's such a beautiful thing. Comrex does that, Tyline does that, Telos Alliance on some of our products do that. So many things, make that available, because we figured out a long time ago that if you have two IP paths that each have 4 or 5 nines of reliability, and you get chances are they're not going to miss the same packet at the same time on both of them. So you stitch those together, and all of a sudden you've got 6 or 7 nines of reliability. And it's a beautiful thing, especially if they have. Well, you need to have 2 different backbone suppliers too. You don't need one backhoe taking out several different local providers at the same time, do you?
Right. Yeah,
Yeah.
redundancy is important in everything, whether we're talking audio, internet, or even air conditioning.
Yeah, yeah. So these days, is it just really standard practice to have 2 HVAC systems at a site?
I can only speak to what I've seen. I like to think that's the case because that's the
Mhm.
way I've generally seen it, and that's the way I like to do it. You really need to have 2 fully identical systems. Um, and then you can keep the hours the same between them. You can toggle either one for whatever reason. Oh, well, this one failed. If you've got automatic, it reverts over to the other one. Or if you've got pseudo manual, if you will, like old school simple thermostats, split them 3 degrees apart. You might get an alarm because it goes up 4 or 5 degrees, and you set that threshold to say, hey, I've got some kind of an issue. But if you split them into that closer realm there, if the one fails, the room is still reasonably okay, and then you can take care of the issue without having you go off the air because your transmitter is at 120 degrees.
So maybe you've heard of this, but I heard a simple way to do this if you didn't have an intelligent controller is if you had a thermostat on each one, set the thermostats, like you said, 3 or 5 degrees apart, and then next week reverse their 3 or 5 degree. Make one of them below the other instead of above the other, and that way you
Correct.
automatically rotate what's going on if you remember to do it.
Correct. And the flip side is sometimes, and I do this with some of our sites, we've got exactly that, but instead of every other week, we
Mhm.
like to get to all of our sites still every 7 to 10 days, but there's a lot of other things we're doing. So, of course, we all know that happens when that happens or doesn't happen. But I'll do seasonal changing on them. I might say, well, this one seems to be a little bit better, and I like the position to provide the airflow into the room or near the transmitters more for the summer. But when it's not 100 degrees outside, I can deal with this one running more so. So I'll run that as the winter lead. And for 6 months out of the year, I run one as the primary and one as the secondary. Like you said, flip the thermostats and then do the same thing the opposite direction 6 months later.
Hey, I just occurred to me if you got to do this a little bit on the cheap. Let's say you can't afford a commercial dual Bard brand system or some other one. If you need to use kind of an ordinary household air conditioning or maybe not, less than industrial. Point is, we were talking about controlling them. Uh, Electronic thermostats with scheduling and remote monitoring and remote control are so inexpensive now. Here at my home, I had a couple that were that actually um, we used them for about 15 years and they worked great. They were Wi-Fi thermostats, but whatever company was handling the remote rendezvous server, basically, they didn't have a good financial model and they quit. So I had to buy a couple new thermostats, and I had a lot of Wise cameras, and I thought, well, I like those. Okay, and the Wise thermostats were a good $50 cheaper than the other ones. So, okay, we'll try those. I guess maybe the Chinese government knows what the temperature is in my house now. But anyway, I put those in, and I just love them. They're just so easy to use. You can use them from right there at the front panel, of course, and they're not complicated. But you can also monitor them remotely. In fact, when I was in Wisconsin with you, or even in Canada last week, my wife would call me or text me, and she would say, "It's a little cold in here. Can you fix that?" And sure, yeah, from half a world away, I'm
Yeah.
up the temperature up or down to make her comfortable. Point is, if you needed to set up a schedule so that your thermostats would change their relationship to each other, their set points, you can do that. And
Yeah.
that would be a very cool thing to do, and not expensively either, and monitor it the whole time.
Yeah, and the other thing you hinted at there as well, I had a site here in Richmond a couple of years ago when I first moved down here that the TPO was about 2.5 kilowatts, but what I inherited at that site was literally a window unit. But if you do the
Oh
math on it,
gosh.
you go back to that one that I shared early on from Jeff Welton with the how many kilowatts of RF and how much cooling does it create and everything. It can
Uh-huh.
work for the math. It was a window unit and it was not ideal, but mathematically it did the job in that regard. And we kept that running for a while until the station was actually sold. Um, it's a lot less expensive than a Bard, and if you've got the right TPO, that's the catch.
Yeah. Yeah, I hear you. Hey, we're talking to Joe Fleming. We're just about done. We're going to come back with a tip of the week here in just a minute. This Week in Radio Tech is brought to you in part by my friends over at Broadcast Bionics. And this week I'm talking to you again about the virtual rack from Broadcast Bionics. They remind you that broadcast hardware that isn't hard. I've been talking for years, and several companies now, including my employer, Telos Alliance, has been coming out with virtualized broadcast products, and I'm using some of these at my own radio station, the new one in Oxford, Mississippi, the Rock Station. We have an HD2 that's oldies and an HD3 that's a light urban AC, and we have virtualized the audio console, and we virtualized the on-air phone system. So our jock in the morning, he basically does a remote every day. We even have these at the transmitter side. You don't have to put your virtualized broadcast stuff at the transmitter site, but that worked out best in my situation. So we basically do a live remote every day from the main control room through a browser. We don't even need a hardware codec. We just use the browser. WebRTC works great, sounds fantastic, high bit rate, and we do it. But installing those virtual components, those Docker containers, those software containers, that can be tricky. That really can. There's a lot of things to worry about, take care of, and it's not a one button install and you're done. But Virtual Rack from Broadcast Bionic has made it easy. You can rapidly deploy containerized broadcast products using Virtual Rack. In fact, their headline is, you can deploy containerized products without being a Linux expert. Now, I've done this myself at their trade shows. You open up you browse in to Virtual Rack, and you're presented basically with a candy store. You're presented with, an app store, if you will, an app store of different broadcast products that you can install. You click on them, they install typically in under a minute each. Now, they're still not licensed at that point. You would need to contact the respective container manufacturers like Telos Alliance or 2WCOM or Sound 4 and license those products. But once you do, bam, you have a working whatever it is you bought. Whether it's an audio console, a phone system, an audio processor, a codec system, that's what the Virtual Rack system does for you. It makes it easy to install these things that can be pretty complicated. Of course, with my system, I did it the hard way. I paid my friends at Telos to install them for me remotely, and that's what you don't have to do with the Virtual Rack system from Broadcast Bionics. You could read all about it at bionics.co.uk, and or the easy thing to do, just do a Google search for Broadcast Bionics Virtual Rack. If you go to their website, you'll also find some videos at the bottom of the page where Dan McQuillan explains how Virtual Rack works. And this stuff is just cool. Oh, by the way, they do have systems for backup. You can buy a second system and it'll back up the first system. They have really cool ways to make all that work. So check it out from Broadcast Bionics. Thanks, Broadcast Bionics, for sponsoring This Week in Radio Tech at bionics.co.uk. Or just Google it or look in the show notes. I'll have a link there. All right, just got a couple minutes remaining here with Joe Fleming. Joe, I appreciate your time, and thanks for Mike Friedman's recommendation of calling you and getting you to be a guest on the show. I appreciate the work that you've done, and which leads to the knowledge that you share with our listeners. I wonder, is there any words of advice or wisdom or website or any tool that you'd like to leave with me and our listeners and viewers?
Probably the one that we all have said many times and have all heard many times. Keep it clean, keep it cool. And transmitters are wonderful things when they're clean and cool. Want to throw in there the one thing I've got notes written on that we didn't mention is, what about the other extreme?
Mm-hmm.
I'm from Rochester, New York, where cottonwood is an issue.
Oh.
That clogs the daylights out of any system for about 2 weeks as it drops that pollen from the trees as those bloom. Every area, you've got your own particular deciduous tree or whatever that says, you know what? I'm just going to wreak havoc for that duration. Once you know that about your particular geographic area, just make it that's part of the scheduled stuff that happens, because whether it's the second week of May or the third week of June and varies every year or whatever, you're going to have your systems just have some kind of problem like that, and pre-schedule with your HVAC guy to say, hey, once this starts happening, we got to have our system taken care of, because it's a half-hour service call for them, but it's a lot better than 3 hours off the air.
You bring up a great point, and one that I forget totally. Thanks, and thank you for reminding me. You may have a system and an environment where changing your air filters every month, 6 weeks or so is probably just fine. But there's probably a couple of weeks sometime during the year where, yeah, your local flora is just craps all over everything. Here in Middle Tennessee, there's about a week or two out of the year where everybody's car is covered with this yellow stuff. And we're lucky. We get to park in a garage, but not everybody does. And if you're not in a garage, your car is going to be yellow when you go out to it. And of course, the car washes are very busy. But that's the period of time when you probably need to change those air filters, maybe every week. If this stuff is bad out there, and some years it certainly is. So thanks for bringing that up. And only you can know what your local conditions are. But that's a good point. Thanks a lot, Joe. All right, Joe. Hey, Joe Fleming, engineer at Virginia Public Media, VPM, has been our guest, along with his studio guests, Big Bird and Cookie Monster. Thank you much, Joe, for bringing those along. And I guess Chris Tarr was stuck in traffic. Didn't get to make it, but he'll be here next week. We got to go. Big thanks to Suncast, getting the graphics up and getting the show on the air as usual. Appreciate that. And thanks to Joe Fleming for your expertise, Joe. I appreciate it, and sharing with everybody else. We got to go. We'll see you next week on This Week in Radio Tech. Bye-bye.